There we are. Go. All right. Okay. Hello, everybody. How's everybody doing today? Aiken, good to see you, my friend. I hope you're doing good. How you been, Aiken? Beast, I hope you're doing good. Welcome. That you could make it out today. I know I'm doing this stream at the same time, but this is when my classes are actually running. So, not to be an insulting kind of guy. That's just how it is. Tore your ligament. Oof. Oof. Well, that doesn't feel too good. Host, thank you for the follow. Appreciate that. Oof, that's gotta hurt. Ouch. That doesn't feel too nice, I ain't gonna lie. Hey, it's Jasmine. Yeah, well, how long for recovery there, Beast? That's not pretty to tear your ligament. Jasmine, good morning. How we doing? How we doing today? 5 to 7 months? Yeah, that sounds about right. Yeah, it's gotta stink. How we doing today, Jasmine? I hope we're doing fantastic. Hope we're doing decent. Yeah, I know. It's a process to repair something that'll take quite a long time. I'm doing great, Jasmine. Today, hopefully, will be a shorter-ish type of day. There's no replacement for me. Oh man. Those things are gonna happen, Beast. Those things are gonna happen. Backup goalkeeper is a center back. All right. Well, that's not too bad. I maybe it won't play at the same level you do, but you know what? You gotta just focus on the recovery process. Hey, Vince, how we doing? How are we doing here? I'm doing absolutely fantastic, Vince. I don't know what you guys, actually, you know what I need? What I'm missing. Guys, I'm missing my drink again. I need to go get my special drink. I went to Mitsue yesterday. Hang on. Get my drink. Hey, ladies. But like a little bit of matcha here today. There you go. Yes, that's the drink of the day here. Well, there you have it. A little bit of matcha can't hurt. Outstanding. All right. Okay. You just see what I study for math compared to what I do. Fair enough. How's everybody today? How's everybody doing? You drinking an iced chai right now? Excellent. Tea drinkers, absolutely 1000% outstanding. All right. I'm not going to argue with you. But yeah, that's what it's supposed to be. It's a class, my man. It's a class. We're here to learn. We're here to have a little bit of fun while we're learning. I don't think there's a problem with any of that whatsoever. I mean, the school doesn't have to be, necessarily boring 24/7. Triple espresso latte with oat milk. Holy smokes! Sneaky Weasel, if I have a triple espresso, and I've had oat milk before, and let me tell you, oat milk is great, but triple espresso, you're gonna You could be awake for like the next 24 hours. That is true. Where are you? Where am I, by the way? We are in the Chicagoland area here, Beast. Oh, you work there. Well, that explains everything. True story. You do a little bit of story time here before we start. I wanted to try an energy drink. Just I've had Red Bull before, and Red Bull doesn't do anything to me. But I tried. I'm like, you know what? I gotta give some of these other energy drinks a try. So I tried. There's Monster and Rockstar and stuff like that. So I decided to try a Rockstar, right? I wanted to see how it was, and I was working at the tutoring center over at Hartford. So I got this can of Rockstar, right? I got this can of Rockstar. I drank it. And I kid you not. I drank it and I was like, okay, it's kind of working and stuff. And let me tell you, Sneaky, you're correct. It tasted absolutely awful. It was disgusting. But I'm like, you know what? You gotta give it a fair try. No matter what, if you invest time and money into something, you gotta give it a fair try. Tried it, and I kid you not, guys, I felt I didn't blink for the next 2 hours. Next 2 hours, I'm just not blinking. My eyes can't blink. It's just like that shot. It's like I was like, oh my god, this is so much energy. Oh my word, it was terrible. I didn't even finish the rest of the can. It was like half a can left, and I'm like, I can't finish this. It's not only disgusting, but it's a little too strong for me. I like only one flavor of Monster. Celsius is pretty good. I've never heard of Celsius, Isabella. Actually, that's the first time I've heard of that drink. I'm doing great, Glomash. How are you? Yeah, I've had the triple shot energy drinks that you buy in the cans from the gas station. I've had that many a times, but I don't actually feel too much from doing those because I've had the double shot cans, like the mocha or vanilla flavors. I could never find it anywhere. Most people don't even like it. Okay, it's not that popular. Oh, well, you could find it on Amazon, I'm sure, if you wanted to order it, coming in the home. This is college level math here in the United States, Beast. Dragon Fruit Red Bull is good. Fair enough, fair enough. All right. Yeah, I found the triple shot on a camping trip with my cousin. Now it's a classic camping trip for us. Fair enough, fair enough. This is college. This is true. All right, ladies and gentlemen. Now let me start with this here because you know what? We've been kind of going at a breakneck speed here. This is like when the end of week 3. Like seriously, the end of week 3, right? We start on the 23rd. Yeah, this is already end of week. Dang. All right. So I'm going to. I know, but okay, guys, we got 14 more weeks to go. Okay, 14. If you can imagine, we are already buzzing through stuff like it is no tomorrow. We are doing absolutely fantastic so far. Some days we'll be going through one chapter in a single day just because of how fast it goes. But I'm going to put a poll here because I want to give you guys a choice here today. So I'm going to put, I'll put up a poll here for just a minute. So I'm going to give you the choice here. You want to do on this fabulous Thursday. You want to do a little bit of a short class. We're going to end off chapter 3 here for today. Or if you want to do a little extra, I can also start a little bit of chapter 4. But I leave it in the democratic hands of my students. And I just listen to whatever the heck you have to say. And I just kind of go with it. So, there you go. I love teaching, I guess. You betcha. Of course I do. And doing this nearly in some capacity for nearly 20 years. I can't really argue with that. I got a busy day. That's fair, Jasmine. A shorter class. A shorter class would be nice. 20 years, no worries. Time goes by when you're having fun. It flies, my friend. You're doing something that when you're doing something that you like, uh, you don't feel like the time goes by. We have 13 people said short, one person said extra. That's fine. All right, so let's go ahead. I'll certainly acquiesce to your demand of doing short here today. So we're going to be doing a example here, which will cover the last couple of sections here of Chapter 3. That's what we're going to be covering here today. Let's do some intros, ladies and gentlemen, and let's go ahead and get started. All right, let's do it. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, ladies and gentlemen, we're going to pick up where we left off last time. Last time we talked about quartiles. We talked about how to find quartiles, all right? Now, we're going to be using this concept here and talking about quartiles where we left off here last time. And today, we're using that in combination with a few other things. Today we're going to be talking about how to construct a box plot from a data set. Okay, so we're going to be constructing a box plot by hand from a data set. And we're going to be putting that all together here at the end of the day. So you'll see exactly how we can basically build it up piece by piece and then seeing exactly how it'll go. I started an N4 math test, and so far I hate it. Well, I hope you don't worry. You needed some help there, Goldmash, just ask. It's fine. But ask after class. I'll be busy right now. All right, let's go to the big board. Let's go to the big board here. All right, so we're going to continue off from what we discussed here last time. We did questions 4 and 5 here, which talks about percentile and quartiles. Okay, so we related about percentiles and quartiles. Now, in order for us to actually go ahead and start how to put together a box plot, we're going to need a few more tools at our disposal. So let's talk about those tools here and then talk about our step-by-step process about how to put this box plot together. So one of the things that we'll need here is we'll need an interquartile range, aka what we call an IQR. So IQR here is equal to Q3 minus Q1. So we take Q3 here, as we discussed here last time, was the 75th percentile, and we found Q1 here, the 25th percentile. We subtract those values from each other, and we get the interquartile range. Now we will be using this interquartile range here. Where is it going to fit? It will fit in these outlier boundaries. I'm going to come back to these here, but as you can see, if we want to find the lower outlier boundary and upper outlier boundary, lower outlier boundary is Q1 minus 1.5 times IQR. Upper outlier boundary Q3 plus 1.5 times IQR. Now, I'm just going to point this out here. Okay. I'm going to come back to this question here, so don't worry. I know it seems like I'm skipping it very quickly, but I want to go through and start the step-by-step process here into getting our box plot put together, where we are going to go ahead and use this because at first blush, it's not so easy to see where this is going to fit in the grand scheme of things. So I want to go through step by step before we have to use this here, and then I'll come back to it ASAP. Okay, so I'm going to skip down here. We'll come back to question 8 as well. But I want to skip down here to question number 9, is how do we construct a box plot? Okay, so how do we construct a box plot here? We're going to go over this very slow. That way, again, we get comfortable with the idea about how to construct this box plot. All right, so let's put it on a split screen here. And let's see how we can go about doing that. All right, so for our example here, ladies and gentlemen, let's go ahead and go back to our friend. Let's go ahead and go back to our friend, the stem and leaf plot. Now let's make up a new stem and leaf plot here. Seeing a few examples here of the stem and leaf plot. So I'll make up some new numbers here. Let's see here. 1, Um, 2, 5, 9, 2, 6, 7, 8. 3. Let's go with 2, 5, 8, 7. 4. Go with 3, 7, 5, and 2. Okay, so here we go. These are the values that we have here, all right, in this particular case. Okay, these are the values in our stem and leaf plot here. Again, I just randomly made these numbers up. They don't have any meaning at the end of the day. All right, it is what it is. All right. Now, let's go ahead and go through each step here carefully, okay? This will hopefully give you also a reminder about what we did here last time. So I know last time we did a little bit of a rushed example, so hopefully we can do this example here. We can go through this a little bit more carefully, and then you can see exactly how we can find some of the values here, in this case, by hand. So let's go over step 1 here. All right, so step 1 here, it says, order the data set and find the median. So that's the first thing that we're going to do here. We're going to order the data set and find the median. All right. So let's have you guys answer this question here right away. All right. How do we find the median again? What do we do first? What do we do first? If we're going to find the median, what do we do to find the median here? Anybody tell me? What do we have to do in order to find the median? All right, n plus 1 over 2 represents what, Vince? I agree with you. What does that represent? Okay, I agree. Number of data items in the data set. So what does that represent, guys? Okay, the position of the median. Good. That's correct, Alyssa. All right, so that's exactly where. So you guys have that correct. We're gonna first find that position of the median, right? Find out where it's located, because we don't know where it is yet, but we do know that it's somewhere in that order data set. Now we don't have to worry about ordering it because I already did put it in numerical order. But yeah, what's our n here in this case? Okay, so you guys got that right. What's our how many data items are in the data set here in this instance? All right, 16. All right, 16 is correct. Okay, good. Excellent, excellent. All right, so we do 16 plus 1 divided by 2. 16, 17 divided by 2 is a pure 8.5. So again, the 8.5 position, all right, is where we're going to find this median. All right. Okay. Let's go ahead and find out what the median is. We don't know it yet, but we're going to get there. All right, so let's count. So 1, 2, 3, 4, 5, 6, 7, 8. And 8.5 will be right where this red arrow will be. And it's going to be right there. Okay, so that's the 8.5 position here in this particular instance. So this 8.5 position here, again, so if the 8.5 position is right where that red arrow is, how do I find the median again? What do I do? Anybody tell me? What do I do to find that number in the 8.5 position? How am I going to find that median there? All right, just add the 8th and 9th numbers together and divide by 2. So, okay, so Vince, I don't disagree. What are the 8th and 9th numbers here? Okay, totally agree with you, Vince. 100%. What are the 8th and 9th numbers here? And then I'll add those together, divide by 2. 6 and 7. Oh no. 7 plus 8. Here. 6 and 7. What are we looking at here? Are we looking at 7 and 8? 6 and 7? 26 and 27. All right, guys, this is why I asked these questions here, because you guys got to understand, these are not just single numbers. Remember, that's why the stem of 2 here is on the outside. So these are not just the number 6 and the number 7. This is the number 26 and the number 27. Okay, so it's 26 plus 27 divided by... Okay, so that's correct here. 26.5 is the correct answer. Okay, good. So we now know that 26.5 here is our median. Great. Okay, easy peasy lemon squeezy. All right, so that's step 1 as part of our process here. Go ahead and start putting this box plot together. All right, again, as you notice here, I am going to go slow over this again, because again, I want you to get comfortable with doing this here in a more consistent process. Fairly helpful. All right. Okay, next. Actually, before I do that, I guess I should ask that. Are there any questions about that before I move forward? Okay. All right, good stuff. Again, if you have questions at any time here, just let me know. Just stop me. Just ask, okay? All right, let's take a good look here at step number 2. Now, step number 2 says to find Q1 and Q3. Okay, so let's talk about how we found Q1 and Q3 last time. Let's give ourselves a friendly reminder, all right? So, first of all, let's look at the 2 definitions here once again regarding Q1 and Q3. Q1, i.e. the 25th percentile, was the median of the data set that is to the left of the median. Okay, so all the numbers that are to the left of the median, not including the median, but just all the numbers including all the numbers to the left of the median, and we want to find the median of that particular data set. Q3 is the median of the data set that is to the right of the median. Now, let's start off and let's just go slow. Okay, let's start off with Q1. All right, so with Q1 here, this is why we draw in the red arrow here in our data set. If we want to circle all the numbers that are to the left of the median, then all the numbers that are to the left of the median is all the numbers that are to the left of this red arrow, which is indicative of where our median is located. I'm going to circle all these numbers here. Are the notes that are taken during a class posted on D2L? Yeah, so you have to watch the video there. I have the blank notes on D2L, but not the filled in notes. No problem. That way we all, we participate a little bit, Not a big deal. All right. Okay. Let's look at Q1 here. We want to find the median of this particular data set. Now, in this particular data set, we want to just go ahead and count how many numbers that we have here, find the position of that median, and then go ahead and identify it. We got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 8 values in this particular data set, 8 data items. So again, the position of this median here, position of the median here in this case, again, will be 8 plus 1 divided by 2. So this will be the 4.5 position. All right, so I'm going to count 4.5. That 1, 2, 3, 4. 4.5 is right here. All right, and I'm going to go ahead and find out what that median is. And again, that's going to be 13 plus 15 divided by 2. Again, same process. So that's going to equal 14. So 14 here, put this down here. 14 is Q1. Okay. Are there any questions so far about that? Any questions? So notice I did the same exact process as I just did before. Okay. Found the position. Took, in this case, because it was even, I took the mean of those two numbers around that said position. And there you go. All right. Okay. Let's do the next part then, which is Q3. You have to do Q3. All right. Now, let's circle all the numbers are to the right. In this case, we want to take the median of the data set that is to the right of the median here. So again, the red arrow indicates the median. We want to circle all the numbers to the right of that red arrow. I'm going to circle all these numbers here. Okay. So all these numbers here are exactly where they need to be. All right, so can anybody tell me here, what is Q3 going to be? What is Q3 going to be here? Find Q3. Q3, the median here, for this case is 36.5. We got 36.5. Let's take a gander here. All right, so let's count here. There should be 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again, we same position here, the 4.5 position. Okay, agreed with you, Vince. We go 4.5, which is right here. Put this in purple arrow. It's right here between, that kind of got overshadowed by that purple there. 35 and 38. Okay, so between 35 and 38. I'm going to take 35 plus 38. We'll divide that by 2. And indeed, Vince is correct. The answer is 36.5. All right, good beans. Okay, any questions about that? Questions about how we found Q1 and Q3. Oh, and a little bit of the hard part here, a little bit. No. All right. All right. So I'm going to move forward here if nobody has any questions. All right. Let's look at the next step in our process. Step number 3. Step number 3 here is, now that we found Q1 and Q3, we want to go ahead and find the interquartile range. All right, or aka the IQR. All right, so let's find that next. Let's find IQR here. Now, as we just defined here, IQR is pretty simple. It's its own individual step here for a particular reason. So IQR is going to be, again, Q3 minus Q1. So really not too hard to do, but it is important to note it as its own separate step. You'll actually, kind of a little disclaimer here. I do this quite often when it comes to certain mathematical steps. Is if I feel that certain mathematical steps are super important, I just separate it out as its own individual step rather than putting them together. I feel that's a lot easier to kind of track certain progress as you're continuing to move forward in doing some of these processes. So if you see like you feel like I'm like one step feels like, oh, why are you putting this as its own kind of little island? I said because of its importance in multiple steps or the very next step. At least you have that little piece of data handy for you to go ahead and use. So in this case, 36.5 minus 14, we're going to get 22.5 here. All right, there we go. All right, very simple IQR, very straightforward here. No problemo. Okay. So the real question is, why is this so important? Why do we want to go ahead and find the IQR here? Well, as you can tell, this goes back to what we just talked about earlier. Let's talk about the next part here, which is now talking about the upper and lower outlier boundaries here. So this step number 4 here is find the lower and upper outlier boundaries. Okay, so find the lower and upper outlier boundaries. Now, just to talk about this here, let me go ahead and state this here really quick. The lower outlier boundary here, I'm going to call, in other words, I call this LOB, just for short. LOB for lower outlier boundary. Upper outlier boundary as UOB. I just don't want to have to, write that in 50,000 times. So, just to make things significantly easier, I'm just going to label it just like that. In any case, the lower outlier boundary is, okay, so please note the difference between both of these. These are not the same, okay? There's a couple of key differences, so please be careful when using these formulas. Number 1, the lower outlier boundary is Q1 minus 1.5 times the interquartile range times IQR. The upper outlier boundary here is Q3 plus 1.5 times the interquartile range. Let's take a look at the difference between the two here really quick. Logatron, thank you very much for the follow. Notice that lower outlier boundary here is involving Q1. Okay, so Q1 minus 1.5 IQR. So first of all, lower outlier boundary uses Q1. Upper outlier boundary uses Q3. Okay, so notice it uses two different quartiles there. Number 2, they have two different signs. Lower outlier boundary is subtraction, whereas upper outlier boundary is addition. Okay, so please note the difference here. It probably confuses a lot of people when they first see it or when they first use it. So I'm like saying, okay, hey, take a look at those key differences so you're not using necessarily the same numbers for like Q1 and Q3 or minus and plus for. So want to avoid those. I see those as mistakes that happen quite often. So, okay. So what about step 4 here? Well, we're going to use these previous results that we have here. Let's find our lower and upper outlier boundaries. Put in lower outlier boundary here. So our lower outlier boundary here is going to be Q1, which is going to be 14 minus 1.5 times our IQR, which we just found here, to be 22.5. Yes, that's correct, Sneaky Weasel. It is multiplication, yes. So 1.5 times 22.5, correct. No. Anytime you need to clarify anything, please ask, okay? I don't care. It's just a matter of I want you guys to understand. So if you guys are confused at any point, please feel free to ask, okay? Okay. Anybody got an answer for me here? 14 minus 1.5 times 22.5? Again, if you get a negative answer for this, that's perfectly fine too, by the way. So don't be like super shocked. All right. It's not a big deal. All right, negative 19.75. Okay, good. All right. Yeah. So I will say this, like I said, if you get a negative answer, that is not a big deal. We're going to be using these outlier boundaries here, lower and upper, as little reference points. So again, I want to point that out here. We'll be using it as little reference, guys. So, but we need to find these values first before we can use them as reference. Okay, great. All right, nice job, everybody. So far, so bueno. All right. So let's look at upper outlier boundaries now. So upper outlier boundary, we're going to take Q3, which we found here previously to be 36.5. And then we're going to add by 1.5 times the IQR here of 22.5. All right. And does anybody have an answer here for our upper outlier boundary? $70.25? Okay. Very good. 70.25? Perfect. You got it. All right. Easy peasy lemon squeezy. All right. No problemo. Okay. So now we have our lower outlier boundary. We got our upper outlier boundary. Again, real question is, what are we doing with these numbers? Where is this going to fit in the grand scheme of things? Let's go ahead and take a look. All right. Let's go back to our steps here. We did step 1. Fine. Step 2, find Q1, Q3. Perfect. We did that. Step 3, find the IQR. Got that. Step 4, found the lower and upper outlier boundaries. Okay. Let's take a good look here at step 5, okay? And then we'll talk about step 6 here, which will have to go a little bit more. Okay. So step 5 here. Oh, put it into color. Put it back in. I'll put in green. Okay, so step 5 here is on a number line, draw a vertical line on Q1, the median, and Q3, and connect them together as a box. Okay, so on a number line, we're going to draw a vertical line where Q1 is located, draw a vertical line where median is located, and we'll draw a vertical line where Q3 is located, and connect them together as a box. Let's take a look at what that looks like here. Let me show you how this is going to. I'm going to go full screen for this one here. Go out bit. So this may be a little tough to read here at first, but I'm going to need these first pieces of information, so hence why I'm just doing this. All right, so notice here we have the median of 26.5. We have Q1 here, which was 14, and Q3 here, which was 36.5. Okay, so we're gonna basically plop each one of those numbers down on a number line. Let me zoom in here because my eyesight, probably just like yours, looking at this screen is rather difficult. All right, let's make a number line here. Now this number line here, we're going to base it off of our data set. So again, we start at 0, we go all the way up to 52, so 1. So basically, let's start off at 0. Let's go by 5s, I guess. Yeah, 5s are real fine. So I'm just going to go by 5s. Again, this isn't like a super exact science here because I'm doing it on, on this paint tool guy. But again, as long as it gets the point across, that's okay. All right, so I'm going to go out to 55 here because 55 is, again, that highest data item being 52. All right. So I need to draw some vertical lines. Let's draw some vertical lines here. We're going to draw one line here at the median of 26.5. So let's find approximately where 26.5 will be. Which will be right about here-ish. And it's not an exact science, but again, right about here-ish would be our median here of 26.5. I'll label it as 26.5, so that way it's easier to follow. Let's also draw a vertical line here at Q1, which is 14. So 14 here. So 14 here is right about here-ish. And then we also have a Q3 here at 36.5. So right about and so all we're going to do here is connect it together in a box. That's it. So there we go. We have successfully connected it into a box, just like so. Okay, so this is part of step 5 here. Before I move forward here, hopefully that makes sense there. Are there any questions about that so far? Any questions? Hopefully following this is pretty straightforward. So far, so good, everybody. We're in really good shape. All right. It's not too bad. Okay. All right, so that's step number 5. Okay, we're going it again, just going slow here, but that's just fine. All right, I'm gonna go to the next step here, and I'll go split screen with this again. I need to show off the box plot here. Okay, I'll put that in black. Okay, so now we are missing one part here of this box plot. And the part that we're missing here are the whiskers to the box plot. Now the whiskers, we're going to have a line coming from on the left of this. We'll have a line coming to the right of this. Now there are certain things here that we do need to go ahead and address. Let's talk about that here first and foremost. So we're going to talk about each individual whisker here. And this has stuff to do with that we found here from before. So let's go ahead and take a look here. So step 6, draw whiskers. We're going to use the following. Let's talk about the left whisker here. So for the left whisker, yes, Jasmine, that is correct. So this is where the lower and upper outlier boundaries are going to come into play. So we're going to read through this carefully here. We're going to go ahead and explain where they actually are going to be useful. So for the left whisker, we're going to draw the whisker to the next data item in the data set, which is bigger than or equal to the lower outlier boundary. Let's read that one more time. We're going to draw the whisker to the next data item in the data set, which is bigger than or equal to the lower outlier boundary. Let's wrap our heads around that for just a moment, because by words, it can be confusing. No question. But let's look at the lower outlier boundary. Now, the lower outlier boundary here we found was minus 19.75. Perfectly fine. My question to you is, now let's look at our data set here. We're actually going to look at the data set here. So here's our data set. Okay, I'm just going to scroll up here. What is the next data item in the data set that is, again, it has to be a data item in the data set. What is the next data item in the data set that is bigger than or equal to minus 19.75? Okay. All right. Very good. The answer here is 1. Want to be sure everybody's here on the same page. Yes. So if you read this carefully here, Jasmine, that's correct. Again, that is bigger than or equal to that lower outlier boundary. So yeah, either the one that's closest or is exactly that lower outlier boundary. That's correct. It's negative, but again, Jasmine, we're using it as a reference point. We're not actually drawing our whisker out to minus 19.75. It is just a reference point. So the important thing is to actually say, okay, that whisker is going to, and this is why I kind of highlighted it this way, that whisker is going to go to the next data item in the data set. It has to be an actual data item. Okay, it can't be just like a random number, and it can't be like the actual outlier boundary number. We're just using it as reference at the end of the day. So again, it's a fair question to ask because it's a common misconception here, which is why I'm kind of stressing this part here as much as I am. So I'm actually going to draw the whisker not to minus 19.75. I'm going to draw that whisker out to just 1. That is the next data item in the data set that is bigger than or equal to minus 19.75. I'll put 1 up above here, and then that will reflect 1. All right. Are there any other questions before I move on? I want to be sure everybody kind of understands where we're getting this this whisker guy from. Okay. No. All right. So again, Carla, take a look. Read this carefully here. All right, Carla. We want to draw the whisker. We want to draw the whisker to the next data item in the data set, which is bigger than or equal to the lower outlier boundary. So if we take a look here at the lower outlier boundary here, Carla, our lower outlier boundary is minus 19.75. Well, what's the next data item in the data set that is bigger than or equal to minus 19.75? Well, the next biggest data item in the data set that's bigger than minus 19.75 here, Carla, is 1. Okay, 1 would be the next number up above minus 19.75. That's why we draw the whisker out to 1. So it has to satisfy 2 conditions. Number 1, it has to be bigger than or equal to minus 19.75. And number 2, it has to be a data item in the data set. So you just can't pick, like I said, you can't pick any number. You have to actually choose the whisker to go out to a data item in the data set. Okay? I know you did these back in the day. Well, yeah, welcome back. Any other questions before we move forward? And anybody else who has any questions, please feel free to ask, okay? Totally forgotten about these? Yeah, I know. Maybe it's been a while. Maybe also there are a few new things kind of thrown in there as well, Sneaky Weasel. Like when we talk about the 68, 95, 99.7 rule. I'm not sure that was talked about necessarily in middle school. Chabby Cheb's inequality, I know, definitely not talked about in middle school. We'll talk about, like, say, probabilities and stuff that you probably haven't seen in, like, high school or middle school. Things that be slightly more advanced in stats. Oh, you had the 68 thing. Oh, I didn't know they taught that. I know when I was taught math, they never talked about that at all. Just not the rule. Oh, okay. They should have just taught you the rule. It's a lot easier to understand because it literally has the numbers in the rule. Like, it's not that hard, you know? In all honesty, sometimes I think you like in school and they take this like really roundabout approach to finally get to where you need to go when you could just go to the most direct approach and still arrive at the same place. I don't understand. Yeah. I had a very hard math level for 8th grade and it was a struggle. Yeah, I really like No, it's like that thing. It's like, why are you going around in circles, man? It's like, please, if there's a consistent way I can directly get to where I need to go, why the heck am I wasting time just trying to go round and round and round in circles? Like, please. It's like, get to the point exactly. Like people talk about, okay. I know this is a comment. This is like a criticism I have personally. Not about you guys, of course. But it's like if we talk about like Common Core stuff. It's like sometimes I think about Common Core, which I was never taught in my school. Right? I was Common Core. I'm like, man, Common Core is just I'm like, you have to go these roundabout ways to arrive at the same answer when you could try like the most direct method of like adding or subtracting and stuff. I get what they're trying to do. Mind you, they're trying to get you to put it in a slightly different way to kind of do the mental math in your head. So I completely understand the motivation. I just think it makes things harder when you get to like college and stuff when you're like dealing with people who haven't used Common Core at all. It's like, well, um, I'm gonna teach you math because I haven't done the Common Core, and it's not really used in college too much anyway. So it's like, okay, yeah. It's like, well, what are we doing here then? What are we doing? Roundabouts and driving. Ooh, roundabouts and driving is fun. I'm gonna be honest with you, Sneaky Weasel. Roundabouts and driving are super fun. Have you ever taken a moped, Sneaky Weasel, and have you ever driven on a roundabout? Let me tell you something. I'll be honest with you. Taking a moped and driving it on a roundabout is super fun. Okay, it is super fun. I did that. So like, I was in Japan, and there's only like basically like two roundabouts in the entire country, and the city that I was living in at the time was one of the two cities like that had a roundabout. And let me tell you, I had a little moped. It was like a Honda Sky, right? Dead serious, right? And I would ride around that roundabout. It was so much fun. Oh my gosh, it was so much fun. I'll I'll, uh, I'll show you what my very cheap scooter back in the day replay looked like. So it was much older than what you see here on the pictures, but this is what I rode around in while I was in Japan. My first year I was living there. It's how I get to work. It looks something similar to this guy. It was like it had a tank of 3 liters of gas, guys. 3 liters of gas. Let me tell you, it was the best. I got to learn how to ride mopeds pretty easy. Jasmine, it was dope. Rain or shine. So I had everything prepared for that thing, right? I had to come in with like nice clothes, and I had this like big rain suit, like literally like a plastic rain suit from head to toe. I had a helmet, and then I would use my helmet and my glasses. I would use my glasses as like goggles or as a way to like drive out the rain. So I'd angle my head in such a way where I didn't even have to worry about rain hitting me and interrupting my vision. I had it down to a science, let me tell you. Using my little Honda Sky. It was so great. It was super awesome. I had so much fun using that thing. No regrets, folks. No regrets. Oh man, I missed that thing. Yeah, exactly. That's exactly right, Jasmine. Exactly the same thing. Like they had those clear plastic rain suits that they would sell for like $5, and you would just grab one, and it would do you wonders. Let me tell you, it's just does you wonders. You just put on the plastic pants, you take on the plastic coat, goes over everything. Absolutely fantastic. Absolutely fantastic, let me tell you. All right, gotta do this other part here. Let me try and do this. All right, we got to do the right whisker here. We got to do the right whisker. All right, so let's do the right whisker here. So for the right whisker, we're going to draw the whisker to the next data item in the data set, which is smaller than or equal to the upper outlier boundary. So we're going to use the upper outlier boundary this time. So our upper outlier boundary here is 70.25. All right, we want to find the next data item in the data set that is smaller than or equal to the upper outlier boundary. So let's go to our data set here. Can you anybody tell me here what data item in the data set, as I put up here on the screen, what data item in the data set is smaller than or equal to the upper outlier boundary of 70.2? Here, 52. Okay. All right. Very good. All right. So the answer definitely is 52. So our upper outlier boundary of 70.25. The next data item in the data set that is, again, smaller than or equal to or less than or equal to, whatever you want to call it, is going to be 52. Again, we have to go out to that data. So let's go draw this whisker out to 52, just like so. Mark that just like so. Are there any questions about that? Any questions about that right whisker there? Feeling good. That's good to hear. I like where we're going with this. I do, Sneaky Weasel. Let's see if anybody else has anything they would like cleared up before we move forward. Okay. All right, so I'm going to go ahead and move forward then. Okay. Now, there is something important to note here regarding box plots. So one thing I do want to point out here, and I've put it down here as the note in our notes, and that is a note. If we have any data items in the data set that are less than the lower outlier boundary or bigger than the upper outlier boundary, these are basically what we call outliers. This is why we call it an outlier boundary. Those are called outliers and are marked with an X. So basically, in the data set, if we have a very extreme value, so let's say for example, let's say our upper outlier boundary is 70.25. Okay, that's what we got here. But let's say, as just an added example, it's not true for this example, but let's say I had a extra value of like 87. Okay, just out of nowhere, like a RKO or whatever. So 87 would be out here. Again, we mark that with an X, and then we put 87 out here. So if we had an outlier, again, a data item that was either less than the lower outlier boundary or bigger than the upper outlier boundary, again, we just mark that particular data item with an X, as that doesn't, that's an extreme value, and it kind of fits outside of the boundaries that we found here in the previous step. Okay, so that can happen from time to time. We just have those extreme values. Okay, it doesn't happen in every data set. In this example, it did not happen that way, but you get the general idea about what you would do there in that situation if it did. Okay, so I'm just going to point that out here, just like so. Sarah's like, no. Okay, all right, I get. Okay. Oh, emphatic. All right. Shakes the fist. All right. Any questions? Any questions about that? So again, those are outliers. That's why we call it an outlier boundary. It's actually regarding any extreme values and what we do with them in case if that does happen within the data set. Okay. All right, and that is about box plots in general, at least for right now. We have one more thing we need to do. Actually, two more things we need to do, pardon me. Okay. Now, the next thing that we want to do here is we're going to answer a question that came before this. Okay. So this is the step-by-step instructions about how to do a box plot by hand. But we also can get one more piece of information. Let's go back here to question number 8. Question number 8 asks, what is a 5-number summary? Okay, so if we talk about a 5-number summary, let's take a look at the 5-number summary here. This describes the data set, all right, as a whole. Again, i.e. summarizing the entirety of the data set using 5 numbers. What are those 5 numbers? Well, as you can see there, we have the low number, we have Q1, we have the median, and then we have the highest value in the data set. So if we take a look here, we just take a look at our previous information. You could look at the box plot as well. You'll easily see it. But you could also look at what you found here in your previous information. And so we see there, we're like, all right, if we want a 5-number summary, our lowest value, our lowest data item here is 1. So I'll put this 5-number summary. Okay, so our lowest data item is 1. The next one is Q1. Q1 we found here in step 2 was 14. Then we found the median. Median here we found in the very first step is 26.5. All right. And we found Q3 here also in step 2. We found that right at the bottom of the screen, which is 36.5. And then we just take our highest data item here, which we have stated here to be 52. And there is our 5-number summary here for this particular data set. Okay. Oh, not too hard. Again, you can easily, the reason why I reserve the 5-number summary until the end is because by that point, you already have all the data, you have all the necessary numbers to make up the 5-number summary. So if you do the steps there, I always reserve it at the end, so making sure that we do all the tough stuff first. 5-number summary is just a nice little fallout from what you found from before doing the steps in the first place. Okay, so not too crazy. All right. Now, we're going to do one more thing here, and then we'll end off here for today, because I promised that this would be shorter, okay, today, and you guys had voted for that. So, the next thing that we're going to do here is I'm going to bust out the calculator here, and I'm just going to showcase here what to do on the calculator. It's going to be pretty much the same thing that we talked about here last time, so nothing that I'm going to be talking about here on the calculator today will be anything different than what we had discussed here before. It will be the same exact steps, but if you'd like to follow along, you're more than welcome to. I don't have a problem with that. Okay. So the first thing that we're going to do here, I'm going to go ahead and I want to enter in this data set here into the calculator. So I'm going to hit the stat key. I'm going to go to edit. Again, if you do have stuff in your lists, don't forget the way to clear them out is to go ahead and hit the up arrow. Make sure you highlight the list, hit clear, and hit enter. Clear out those lists just like so. Okay, let's look at list 1 here. L1, we're just going to enter in all the numbers in the data set here in L1. Again, this is what we did here last time, so nothing too crazy. It's exactly what we had set out to do. 32, 5, 8. Okay. So in this case, we have all 16 data items in the data set already set and ready to go. All right, so what do we do next here? Well, we're going to do the same exact steps that we talked about here last time on the calculator. So I'm going to quit to the main screen, second in mode. I'm going to go ahead and hit the stat key here. I'm going to go over to calc. I'm going to go to our good friend, one var stats. Wait, how do we clear? Again, hit the stat key, go to edit, highlight the list, sneaky weasel, hit the clear key, and hit the enter key. Okay, so hit the clear key once you have it highlighted on the list here, like you see here on the screen. Hit the clear key and hit the enter key. If you forget, write that down so that way you give yourself a friendly reminder, okay? Hopefully that helps. All right, let me go back here for just a moment. Again, we're going to go to calc. I'm going to go to one var stats, and I am going to call upon list number 1 here, L1. So again, I'm going to do the same thing that I did here last time. Oh, I was just pressing the wrong button. Yeah, just be careful about that. Don't press the wrong button, i.e. the delete key. Never use the delete key, folks. You will regret that decision in the lists. You'll regret that decision very dearly. All right, so we're going to use, in this case here, we're going to use the same thing we discussed here last time. We're going to do one var stats. And even if you're using the old school calculator, you're going to do L1. Again, what would that look like here once again? Again, just the same thing as last time. I'm going to show old school method here in just a second. Show ya. Should look just like this. Again, to get L1 to show up, again, you hit second and 1 for L1. Okay. So that shouldn't be too bad. And this is what we end up with, just like so. After I enter in the, yeah, sorry about that. There you go. After I enter in the set, what's the next step? Hit second in mode, Jasmine. So this is just basically what we did here last time. And then hit stat, and then go to calc. And var stats. That right there. Want, hang on a second. L1. L1 is just trying to get this all down. Second. There we go. All right, I got that. All right, just making sure we got those button presses now. Okay. Okay, so if you have these numbers here, that's fine. All right, I don't have a problem with that if you're trying to just kind of follow along a little bit. The most important part I want to show off here is if you notice here at the very bottom, this is how we found our mean and standard deviations that we talked about here last time. But the most important part that we want to talk about here is we want to talk about some of the key pieces of data that we found here today. And that is here at the very bottom of the screen. So if you notice here, our minimum value here in our data set was 1. We are given our Q1 here is just 14. We did find that here, no problem. All right, we are also fine if we hit the down arrow, we can keep scrolling down here. The median is 26.5. We did find that in our first step, just like so. Our Q3 here was 36.5. We did find that as well. And then we finally found our maximum value here, which is 52. Again, our whiskers don't necessarily go out to 1 in 52. They just happen to work out that way. But again, you'll have to check it with your outlier boundaries in order to make extra sure where those whiskers go out to. So please keep in mind, it's not always going to go to the lowest and highest data items in the data set, okay? Don't make that assumption. First check your outlier boundaries and then see where it goes with which data item. Because, again, like I said, you could have extreme values in your data set, so you have to be careful. All right. Are there any questions about that? Any questions? Any questions about box plots or the like? Any other questions you guys have? Yes, that's correct, Jasmine. The thing is that with the calculator, although it could tell you like a few pieces of information, it's not going to tell you everything, especially not the box plot, obviously. Every time I get to 1-bar stats, the numbers are completely different from yours. Well, I'm not sure what numbers you entered in there. Let's go ahead and take a look here at make sure that the numbers match, again, our data set here. Again, 0, 1 would represent 1, and 4, and 12, and 13. Okay. Vince is asking, what's the homework for today? So probably, if you haven't started 3-3, then a good 3-3 here. 3-3 to 3-5 if you haven't started 3-3. If you have done 3-3, then you're in good shape, but then just finish off the rest of Chapter 3. Probably would be the ideal situation here. So effectively, this is the end of Chapter 3 right here. So just to serve as a reminder, everybody, the first test is going to cover Chapters 1 to 4. So we're not quite there yet for all the material for the first test, okay? So rest assured, there's time to do that stuff. You know, like I told you guys before, I'm going to give you plenty of warning about when that stuff's going to be due. I'm going to give you a lot more extra time after I give you that warning in order to get stuff done for that first unit. So, but did you check that there? Hopefully, did we get the numbers there correct there? Bebenik? Check number 9 in the notes. Yeah, sure. There you go. There's number 9. Right, so there you are, Alyssa. Let me know if you got those numbers down and whatnot. All the homework is on my math lab, yes. Okay, you got it? All right, perfect. Yeah, all the homework is on my math lab, including the tests. That's correct. There are no additional assignments on D2L outside of just acknowledging the syllabus and registering for my math lab. Okay? That's it. All the homework is always on my math lab. So, all homework, all tests are on my math lab. Do we get multiple attempts for tests? Yes, that's absolutely. You get, I believe I put 5 attempts. I gave you a time limit of 10 hours for the test. And then you get 5 attempts. Yeah, look, you can take it like, okay, so that's a great question there, Sarah. You can take it at your own pace, okay? If you want to work ahead, you're more than free to work ahead, okay? Because everything is posted and ready to go. So if you want to work ahead, feel free to work ahead. If you want to work with the pace of the course, then work with the pace of the course. So you know you're keeping consistent with how we're doing the lectures here. Again, whatever you want to do at the end of the day, that's how I'd like you to do it. Okay, I'm not going to tell you, yeah, you got to do it my way or the highway. No, do it the way that you're comfortable with. That's why I'm sending this out here, to be doing it at a pace that you're comfortable with. Oh, okay. I think I know why. It's set to L3 and L4. I think it's because you deleted out the first two lists of L1 and L2. But you can hard reset the calculator if you want, and then get L1 and L2 back if you like. Yeah, if you want to get it done ahead of time, that's perfectly fine. Okay, I don't mind about that. Sarah has a random set. Yes, okay. Yeah, so Sarah, if you want to take it ahead of time, please be my guest. I don't have a problem with that. Trust me, I'm not going to be insulted. I want you to work however you want to work, okay? I'm going to give you a due date about when that unit's due with the test and the homework related to that unit. Outside of that, how you want to get that done is completely up to you. The only thing I always say is that please don't leave it to the last minute, because it usually ends up to be an absolutely beautiful disaster. So, and yeah, it's pretty bad. So, yeah, make sure you hard reset your calculator if you have L3, L4 as your lists, because that's the only way you're going to get them back. All right. Anything else? Anything else anybody else would like to ask before we head out here for the week? No. I told you it was going to be a shorter class today. I told you, I promise. I did it. All right. Let's go to the big screen here. So I could show you here really quick. If you want to hard reset your calculator if you're missing your lists, you can hit the second key and the plus key, go to number 7, which is reset. Okay, go to 7, and then go to reset. I'll show this, actually, this on this here. Thank you, Vince. You take care of yourself. Let me just I'll just end this off here real quick. You go to the reset here, number 7, Bibinek, and then you go to all RAM, and then you say number 2. You go to number 2 and reset. Then if you go back to your list, everything will be wiped out, but you'll have L1 and L2 instead of L3 and L4. So just letting you know, that's how you would go ahead and do that there, and get that set up and good to go. Okay. All right. In any case, I want to thank everybody very much. Thank you so much, everyone, for coming on Aja's stream once again this week. You guys are absolutely fantastic. I love all of you guys. All of you are absolutely wonderful. Thank you so much. You guys did a wonderful job here today. We're getting out here a little early, as you guys said. Hey, you want a little bit of shorter? I said that's fine. We're working at a very nice, brisk pace. We're done with 3 chapters in 3 weeks. I can't ask for more. All right. Everyone, have yourself an absolutely fantastic, wonderful weekend. I hope you get a nice chance to relax, enjoy yourselves. All right, take it, get a little rest in, get a little homework in. All right, and we will be back right here on Tuesday, same time, same place. Everybody, we'll be back to start chapter 4. All right. Have a great one, everybody. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Have a great one, everybody. Take care of yourselves. Have a wonderful weekend. We'll see you later, everybody. All right. Bye. Bye, everybody. Take care of yourself.